The James Webb Space Telescope found galaxies that shouldn't exist. Not just one, not just a few, dozens of them. Massive, bright, perfectly formed galaxies shine in a period of the universe when, according to everything we understand about cosmology, they simply couldn't be there yet. And the more we look, the worse it gets. For nearly a century, we built a timeline of the universe. We calculated how long it takes for stars to ignite, for galaxies to assemble, for supermassive black holes to grow. The math worked, the observations fit, the story made sense. Then we pointed humanity's most powerful telescope beyond our galaxy, into the deepest reaches of space and time. What we found didn't just surprise us, it threatened to unravel the entire story. And some scientists still can't believe what they're seeing. When you look into space, you're looking back in time. Light travels fast, but the universe is incomprehensibly vast. The light reaching us from distant galaxies left its source millions, even billions of years ago. Picture this: the farther we look, the further back we see. Before James Webb, our most powerful eye on the universe was the Hubble Space Telescope. For over 30 years, Hubble revealed the cosmos in unprecedented detail. It showed us galaxies in their adolescence, stars being born, the remnants of cosmic violence scattered across the void. But Hubble had limits. It could see back to around 400 million years after the Big Bang. Beyond that, an impenetrable wall. The earliest light was stretched so thin, so red, that Hubble simply couldn't detect it. The cosmic dark ages remained hidden. James Webb was built to shatter that wall. Unlike Hubble, which sees primarily invisible light, Webb observes in infrared. This means it can detect the ancient, stretched light from the universe's first galaxies, light that has been traveling for over 13 billion years. When Webb opened its golden mirrors in 2022, astronomers expected to peer into the cosmic dark ages. They expected to find small, chaotic clumps of stars, proto-galaxies just beginning to pull themselves together. What would you have expected to see in the infant universe? That's not what they saw. Within the first images, something was wrong. Imagine the moment researchers gathered around screens analyzing data from the edge of time itself. What they saw made them check their instruments, then check again. There were galaxies everywhere, not faint, scattered dots. Fully formed spiral and disk galaxies, some nearly as massive as the Milky Way, shining brilliantly in an era when the universe was only a few 100 million years old. One astronomer later admitted they spent 3 days rerunning calculations, convinced there had been an error. There wasn't. One galaxy, catalogued as Glass Z13, appeared to exist just 300 million years after the Big Bang. Another, CEERS 93316, seemed even older. At first, teams were cautious. Early data can be misleading, distance measurements can be off, but as more observations poured in, the pattern became undeniable. These galaxies weren't just present, they were thriving. But here's where it gets truly strange. To understand why this is so shocking, you need to understand how galaxies are supposed to form. Imagine the beginning. The universe was nearly uniform, a hot, dense soup of hydrogen and helium. But tiny fluctuations in density, quantum ripples from the Big Bang itself, created regions where gravity could begin pulling matter together. Slowly, over hundreds of millions of years, gas collapsed into the first stars. These stars gathered into clusters. Clusters merged into larger groups. This process takes time, immense amounts of time. Now picture building a galaxy like the Milky Way. You need hundreds of billions of stars. You need them organized into spiral arms. You need a supermassive black hole at the center. You need time for all of this to happen. According to our models, the first galaxies should be small and messy, irregular clumps, not the grand spirals we see in the modern universe. Yet James Webb found something impossible. Galaxies with masses reaching tens of billions of solar masses, existing when the universe was barely 500 million years old. Supermassive black holes that appeared impossibly large for their age. It's like finding a towering oak tree growing in soil that was only planted yesterday. And then came an even stranger discovery. In July 2022, astronomers analyzing Webb data identified 6 massive galaxies from 500 to 700 million years after the Big Bang. Each contained as many stars as the Milky Way does today, a galaxy that took over 13 billion years to build. One researcher described it as finding a modern city in the archaeological record of ancient hunter-gatherers. Suddenly, the timeline we'd relied on for decades was called into question. Then came the discovery of ancient quasars, brilliant beacons powered by black holes millions of times the mass of our Sun. These monsters were shining when the universe was less than 1 billion years old. How did they grow so fast? Our models say it's impossible. Black holes grow by consuming matter, but there's a physical limit to how quickly they can feed. Even under ideal conditions, they shouldn't reach such sizes so quickly. Unless something about our understanding is fundamentally wrong. What would that mean for everything else we think we know? This isn't just an academic puzzle, it's a crack in the foundation of modern cosmology. For generations, scientists have refined the story of cosmic evolution. The Big Bang, inflation, the formation of the first atoms, the Dark Ages, the first stars, galaxy assembly. It's a narrative supported by decades of observation, mathematics, and theory. That story is how we understand our place in the universe. It's how we know where we came from and potentially where we're going. But what if the story is incomplete? What if we've been reading the book of the universe with pages missing? Several possibilities have emerged, each with profound implications. The first, our understanding of galaxy formation is wrong. Perhaps galaxies can assemble far more quickly than we thought. Maybe dark matter, the invisible scaffolding of the universe, clumps together faster in the early cosmos. Maybe the first stars were far more massive, burning brighter and faster, accelerating the entire process. The second, our measurements are off. Perhaps some of these galaxies aren't as distant or as old as they appear. Dust and other factors can complicate distance estimates. But as more data accumulates, this explanation becomes less convincing. Now here's the possibility that keeps cosmologists awake at night. The third and most unsettling option, our cosmological model itself is flawed. The lambda-CDM model, our standard model of cosmology, has been extraordinarily successful. It describes the universe as composed of ordinary matter, and dark energy. It predicts the cosmic microwave background, the distribution of galaxies, and the expansion rate of the universe. But it's built on assumptions. What if one of those assumptions is wrong? Imagine discovering that the foundation of your house was built on sand. That's what this feels like for physicists. Some researchers have begun exploring alternatives, modified theories of gravity, different behaviors for dark energy, variations in the fundamental constants of physics in the early universe. None of these are mainstream, none are widely accepted, but the observations from James Webb are forcing scientists to ask uncomfortable questions. Questions that could reshape our entire understanding of reality. In early 2023, another anomaly surfaced. Webb observed a galaxy named ZFUDS 7329. Teams ran spectroscopic analysis breaking down the light into its component wavelengths, searching for clues about the galaxy's age and composition. What they found stopped them cold. The galaxy contained stars that appeared to be older than the galaxy itself. That should be impossible. Stars are born inside galaxies, they can't predate their own birthplace. Yet the stellar populations in this galaxy seem to have formed earlier than the galaxy's apparent age. Researchers spent weeks checking the data, running simulations looking for errors. The results remained the same. Either the measurements were wrong, or something very strange was happening in the early universe. But the mysteries didn't stop there. Then there were the shapes. Conventional wisdom held that early galaxies should be chaotic and irregular, gravitational messes still pulling themselves together. Instead, Webb found elegant spirals, neat disks, structured forms that suggested stability and age. Picture this: you're expecting to see a construction site and instead you find a finished skyscraper. How do you build order from chaos that quickly? One image captures the strangeness perfectly. In Webb's deep field observations, you can see galaxies layered across time. In the foreground, relatively nearby galaxies a few billion light-years away. Behind them, more distant galaxies from the universe's adolescence. And scattered in the deepest background, tiny red dots, ancient galaxies shining when the cosmos was in its infancy. Some of these dots are brighter than they should be, more massive than they should be, more evolved than they should be. Every single one is a question mark burning across cosmic history. We've spent centuries expanding our perspective. First, we learned Earth wasn't the center of the solar system, then that our solar system wasn't the center of the galaxy, then that our galaxy was just one of billions. Each revelation humbled us, each forced us to rethink our significance. Would you have accepted these discoveries easily, or would you have clung to the old certainties? Now we're learning that even our understanding of time itself, cosmic time, the unfolding of the universe from the Big Bang to today, might be less certain than we believed. If galaxies formed faster than we thought, what else did we get wrong? Are there entire chapters of cosmic history we've misunderstood? Are there processes, forces, or phenomena we haven't even conceived of yet? The universe might be stranger than we can imagine. Here's what we know for certain. The James Webb Space Telescope has detected massive, fully formed galaxies in the first billion years of the universe. It has found supermassive black holes that grew faster than our physics can easily explain. It has observed structures and stellar populations that challenge our timeline of cosmic evolution. These aren't errors, they're not flukes, they're patterns. And they're forcing cosmologists to confront an uncomfortable truth. The universe may be far stranger, far more complex, and far less understood than we thought. Some scientists are calling it a crisis in cosmology. But others see it differently. They see it as an opportunity, a chance to refine our models, deepen our understanding, and discover new physics. A chance to expand human knowledge beyond its current limits. Because that's what anomalies do, they point the way forward. When observations don't match predictions, it means we're on the edge of something new. Every major revolution in science began with data that didn't fit, with observations that refused to cooperate with established theory. Galileo's moons of Jupiter, the orbit of Mercury, the cosmic microwave background, each was an anomaly that transformed our understanding. James Webb's impossible galaxies might be the next. And if history is any guide, what we discover could be far more incredible than what we expected. The story isn't over, it's barely begun. Webb will continue observing, collecting data, peering deeper into the cosmos than ever before. Each observation adds another piece to the puzzle. Each spectrum, each image, each data point helps astronomers refine distance estimates, confirm masses, and understand what they're seeing. Right now, new theories are being proposed, simulations are being run. Researchers around the world are collaborating, debating, testing ideas against the evidence. Maybe we'll find that galaxy formation is more efficient than we thought. Maybe dark matter behaves differently in the early universe. Maybe there are feedback mechanisms we haven't accounted for. Or maybe, just maybe, we're about to discover something entirely unexpected. Something that will rewrite the first chapter of cosmic history. Beyond the Milky Way, in the deepest reaches of the universe, galaxies that shouldn't exist are shining. They're older than they should be, larger than they should be, more complex than our best theories predict. They're telling us something. The question is, are we ready to listen? If Webb's discoveries are challenging everything we thought we knew about galaxy formation, which possibility do you think is most likely? Are our models wrong, our measurements off, or is something deeper broken in our understanding of cosmology? Let us know what you think below. And if you want more evidence-based space documentaries that explore the biggest mysteries at the edge of human knowledge, subscribe and join us for the next journey into the unknown.